this would equal 4.5. This would equal 4.5 times the square root of 3. Well, if I type that in my calculator, different calculator, what happens a lot of times with the multi-view, if you put it in with a decimal, it's going to spit out a decimal. It's not that it's an incorrect answer, but if I ask you for simplified radical form, you want to remember, okay, if you just gave me this really ugly looking decimal, what did I just type in my calculator? I just typed in 4.5 times the square root of 3. Well, that 4.5 times the square root of 3 is technically the correct answer. That is what you call simplified radical form. Now, if you use the 9 over 2, if you use that 9 over 2 with the fraction bar, 9 over 2, and you do times the square root of 3, it'll put it in that format, 9 root 3 over 2. Okay. I just wanted to show you, because sometimes when you get halvesies, it might give you the fraction bar stuff, or it might give you decimal. So if you ever get a halvesy, use the fraction. That way you know that for certain it will automatically generate the radical form. Okay? Does that make sense with that? It's usually the halvesies that do it. Okay? Because I know you guys say, oh, it's 9, it's half of it, it's 4.5. So if you wrote 4.5 root 3, that would be a fine answer. Or 9 root 3 over 2. Either one would be okay. But just try to stay away from decimals with these things. Okay? Does that make sense? I know it's just a little bit of a weird thing. What I also wanted to walk with you guys through is a little reminder of where we're at this week. We have one type of problem to talk about today, and that's with the specials. And then tomorrow, one type of problem for today, nothing real crazy. Tomorrow, since it's Monday, tomorrow we're going to quiz, like I said last week, over the first 2 sections, and it's all this. Oops, it's all the same stuff. And then on Wednesday, we start trig. And one of the things that I want to let you guys know about with our textbook is that it doesn't do a really good job of how trigonometry is presented to you guys for the first time around with it. So we're probably not going to use most of the textbook stuff at all. We'll be working off of just notes and worksheets, stuff that I've made that I've used in the past that are a lot cleaner, if you will, for how to build up the background for it. This trig stuff usually takes a good week and a half or so to get through. It's technically about 2 or 3 sections worth of stuff in the book, but we go nice and slow through it because it's kind of important to understand how that stuff functions. Questions I have? Well, let me show you the thing I was talking about then. The one style problem that we have yet to look at looks like this. And that's when you have 2 special triangles put together. When you have 2 special triangles that are put together and solving out that way. Let's see, let me pull this up for you. Now, in the past, what we've been doing is that we've been solving for all the missing side lengths, which isn't been a big deal, because it's all the same process each and every time, just different numbers. What's different here is that it's technically only going to be asking you to find one side length. And it becomes more or less up to you. Remember, this is just the missing side. Don't worry when you see X's for things like that. What it's trying to get you to do is find just that one side length, but you have to make a decision as far as how to get to that spot. And you have to use the specials to wrap yourself into it. Not a real tough thing, but these are where some of the numbers get kind of messy if you're not careful. Right? So first thing you always do is you identify which of the two triangles in this case, or three triangles, whatever it might be, which across from what angle do you know? So in this diagram, across from what angle do you know? A 30, good. Since I know it's a 30, I go ahead and start by writing out my 30s. The 30, the 60, and the 90. It looks at x, it looks at x times the square root of 3, it looks at 2 times x. And you're filling it through like that. Okay? Notice how I'm starting it just like we have every other problem, because if you start it this way and you write it this way, you'll be less likely to screw up using this way. So just like you just told me, you know across from the 30, that side length equals 10. Which means everywhere else in that triangle, I see an x, what would I put? 10. So I know across from here would be 10 times the square root of 3. Across from the 90 would be 2 times 10, which is 20. Which of those other two side lengths do I need to get to the other triangle? No, the side length, but you're right, I'm going to a 45, but do I need the 10 root 3 or do I need the 20 to get to the next triangle? I need the 10 root 3, very good. Everybody see that? I need to use the 10 root 3 to get to here, so then I can figure out what's across from the 90 and the other. Okay. So you're using one of your answers to get to the next answer. And you start to do this a lot more with right triangles, and in trigonometry, we have to reuse answers. Okay. So in the next part here, that 10 root 3 is now in the second triangle. What side is it across from? A 45 or a 90? Yep. So you just rewrite 45, 45, and a 90. Move this up a bit here. So it's across from a 45, which means the 45 is looking at a side length, which is 10 root 3, which is 10 root 3, which is 10 root 3 times the square root of 2. Which one of those I need to press into my calculator? The 90, yeah. And you quite literally type it in just like that. One thing I will caution you on, remember how when you type in a square root symbol, it looks at over bar, it goes underneath the radical? Right, your 10 square root 3. Notice how that it's still underneath the radical? I have to make sure I hit the right arrow to get out from underneath it before I hit the times root 2. That's a common mistake. Just be careful with that. Just watch what you're doing. You get 10 root 6. Okay. Not terrible. And that's what we're looking at today. Just adding that one extra piece to it. Right on. So you write out your three side lengths. The 30, the 60, the 90. It looks at this. It looks at some value of x times the square root of 3, and 2 times that. So you have to set the 60 equal to 9. How do you undo multiplying by the square root of 3? Multiply by the square root of 3. Once again, this is where that calculator becomes your best friend. When you divide that by the square root of 3, I believe you get 3 root 3. So that means that your value of x is 3 root 3. Where do I need to place that value to get it to the next triangle? Do I have to put it across from the 30 or across from the 90? Yeah, the 30. I got to put it across from the 30 to get it here. Now that side length is across from what side? From what side length? Across from a 90 in a different triangle. Okay. And you continually rotate it through. It's now across from a 90 in a excuse me, in a 45, 45, 90. So that means that something times the square root of 2 equaled 3 root 3. Which means, what do you do to solve for x? Yeah, divide by the square root of 2. Do you see what I'm saying about you're starting to get a lot weirder looking numbers when you do that? 3 root 6 over 2, I think. Is that right? And that goes across from the 45s. It's okay. I just saw the whole. You're just reusing. You couldn't hear all of it before. Does that make sense for where we're getting it from? One step out from problem at most. It really is. Excuse me. I'll generate one of these for you to do on your own completely. Let's see, I love being able to do this automatically. It's kind of nice. Ooh, look at that. You don't have to worry about making up stuff on the go. I can just press a space bar and it makes a new problem. Because of math. All right, try that one. So what side length do you know across from to start with? A 60. So you start by writing out the ratios. So you know across from the 60 is something times the square root of 3. Well, in that case, that has to equal 8. So that means you have to divide by the square root of 3. Oops, so I can write correctly. And if you did that, you should have gotten 8 root 3 over 3. Correct? Now, do I need to take that value of x and put it with across from the 90 or across from the 30 to get to the next triangle? Correct. I have to put it across from the 30. So that gives me the, oops, 8 root 3 over 3 there. Now that is into a new triangle. That's a 45, 45, 90. And we happen to know that across from a 45. So now I take that value of x and I put it times the square root of 2. And I think you should get, did you get 8 root 6 over 3? and you're done. That's what that looks like. Yeah, remember, as you write these things out, and here's the thing, if you typed in root 3, but you wrote down you did a root 2, you know what I mean? If you actually hit the 3 again, I would know what you did wrong. I could figure that out. And it's really, really, really important, especially as we go along in trig, to write down what you're going to put into your calculator before you put it in your calculator. That way we can see where you messed up if you did get something wrong. Okay. Yeah, that was really the only other one new thing I wanted to show you. So let's go back through the rest of the stuff we've done, and I have some review junk for us for the rest of the afternoon. What is this? Pythagorean theorem. Okay. When do you use the Pythagorean theorem? For right triangles, very good. You use, ladies and gentlemen, you use Pythagorean theorem when you have right triangles, and you use Pythagorean theorem when you have right triangles and you're trying to find side lengths. How many sides do you have to know to use Pythagorean theorem? 2 of them. You have to know 2 of them. Now the other thing is, when you have Pythagorean theorem, you need to have 2 out of the 3 sides to make it work. Whereas with the special right triangles, you only need 1 side. And the only reason why you use the specials is they're still right triangles, but you can only use a special right triangle if there's a 30-60 or a 45-45. It doesn't mean that the Pythagorean theorem wouldn't work, but you'd have to know it more information. Now, if I'm trying to find that missing side length there, if I use 7 and 24, is the missing side length a leg or a hypotenuse? How do you know? Correct. Everybody hear her?
The hypotenuse is across from writing.
We're so bad. Correct. This never changes. The hypotenuse, the location of the hypotenuse never changes. That's also going to become pretty important when we start doing trig stuff on Wednesday, because we're going to use the hypotenuse as a question that we're going to ask ourselves all the time. Do we know the hypotenuse? And we go from there. So you write it out as 7 squared plus something squared is 24 squared. In this case, you're just doing basically a 2-step math problem. Press some buttons in the calculator and go. You know that that's 49, I don't know, something into the 6. So x squared will equal 24 squared subtract 49. What's that? I did figure it out. Press the button. I did. Sorry, I forgot it was 576 or 586. Sue me. Why are you so mean to me? And then you just take the square root. And did you guys figure out by using just the answer button, it's pretty easy? Second square root of your answer. And then yeah, I know, she's just trying to be. When it comes out and you get an answer of the square root of 527, what does that mean from your calculator? It means that it automatically simplified it and it can't be simplified. Okay. You know how sometimes you hit enter, it'll say 2 root 3, something along those lines? In this case, if it doesn't change it, it just can't be simplified and you're done. And that's why it always says leave your answers in simplified radical form, and that's what it automatically does. Okay. What's that? Very well. Why did we write the c squared first? When we did to tell what kind of a triangle you had. What's that? The inverse. Oh, I know where you're going with that. I'm sorry. I know because you're saying if c squared equals. Yeah, that's where you're going. Yes, you're right. I'm sorry. I was thinking of inverse operation. Sorry. When you put the c squared value first, if it equaled the other two sides squared, it was a right triangle. If it was bigger, what kind of triangle was it? Obtuse. Which by a process of elimination tells me this one is going to be. You don't want to go for that one? That's why we wrote it first. So if the c squared equaled the sum of the other two squared, a squared plus b squared was a right triangle. If c squared was larger, it was obtuse. If it was smaller, it was a cube. And the reason why I put that the c squared first is because it follows the idea if something's bigger, it's obtuse. If it's littler, smaller, makes sense. It was a cube. Okay? So that was one thing we did there. When we had stuff, you had side lengths. For example, if you had side lengths of 5, square root of 61, and 6, how do you know which one of those has to be playing the role of the c? What's bigger? Now, do you know what the square root of 61 equals? No, but how do you figure that out in the calculator? Correct. Yeah. Now, in this case, when you type in the square root of 61 in the multi-view, it gives you an answer of square root of 61. That doesn't help me very much, but if I hit the double arrow button, it gives me 7-ish, right? So which of those is playing the role of the value of c? Middle. So then you fill it out that way. You will put in the calculator the square root of 61 squared. What's that? Is it closer to one or the other? That's exactly right. Yep. You're spot on that one because square root of 61 is between the square root of 64 and square root of 49. It's closer to this one. It's more than halfway close to it, so I would have said 7.7-ish. You did the right thing. You were doing it just fine. Why do I put square roots? Or why do I put square roots in parentheses before I square them? What's that? Yeah, you could ruin the answer. It's hard to screw up with the when you have just the square root of something. But if there was a number in front of the root, if it was 2 root 61, if you don't put, if I had, let's say, just the square root of 5, and I squared it, it'll just give me the answer of 5, because there's no number in front of it. But if I did 2 square root 5 and squared it, it would give me that, as opposed to the real answer. It's just one of those things you just got to be careful with. So that way, anytime you're squaring something that has a square root symbol in it, automatically throw it in parentheses. That way you know it'll be really, really hard to screw up. I wouldn't put it past you, but it's going to be a little bit more difficult. Okay. So what's 25 plus 36? And the square root of 61 squared is that a right, acute, or obtuse triangle? Right. So we did that. What else did we do? And those are specials, I believe that. Let me give you a few. This is nothing very difficult. This is very similar to what we've been doing. Same complexity. Those last four on the back are what we did at the beginning. Everything else is just all straight review. Yeah, I'll give you a little time now to start it. You got a couple minutes to get going on it. Make sure when you're doing 45s and 30s and 60s and specials, you write out what you're doing before you do it. 6 minutes. Ah. Yeah.
Yeah. Okay.
Come on, Slacker. Let's go. Slackers, let's go. I know I've asked up enough. Jeez. Yeah. Did you get right out the ratios and get started on all of it? It's not going to kill you. I did. Don't BS me. Get started. Don't BS me. Not my first day. Guys, got work to do.
You